Hello students, today I am going to cover lecture number 4 of unit number 5, which is SNMP. So it is basically a application layer protocol. In this we will discuss how the network can be managed, what are the components of SNMP, and what are the basic characteristics. So we will go through one by one. So firstly, go through the definition. SNMP means simple network management protocol. If suppose that I have thousands of router, all the switches, so it will be a little bit difficult to manage each individual one by one. How the network administrator can configure those if there is something wrong, how it will manage, or how will it correct the faults. So to overcome from such type of problems, there is a concept of SNMP. If a organization has thousands of the devices, then to check all devices one by one every day, are they working properly or not, is a hectic task. To ease up these up, simple network management protocol is used. Simple network management protocol is an application layer protocol used to manage and monitor the network devices such as routers, servers, switches, and their functions. So there are two components. First one is the manager, second one is the agent. So we will discuss in the later slides how the manager can manage the agents. SNMP uses the concept of manager and agent. Manager is usually a host, control and monitor the set of agents. Means manager can manage a number of agents. Agents are the routers, switches, computers, etc. In general, it is router and server or switches. SNMP is a application level protocol in which few managers stations control a set of agents. The protocol is designed at the application level so that it can monitor the device made by different manufacturers and installed at different physical network. This may be possible. The devices are not connected directly, means they may be in the other networks. It can be used in a heterogeneous internet made by the different LANs and the WANs connected by the router by different manufacturer. So here this is the manager and these are the agent. In general, here in the diagram, agents are the routers and agent will have some agent variable. So basically agent variable plays an important role. We will discuss little bit later. Manager. A management station is called a manager. A host that run SNMP client program. A managed station is called agent or a router that runs on the SNMP server program. Management is achieved through the simple interaction between the manager and agent. The agent keeps performance information in a database. The manager has access to the values of this database. Means each agent each agent have some specific value that are known as the agent variables, and these agent variables along with their values are stored in the database. The manager access those database and check out the values. If there is some problem, it will rectify or correct it. Agents can also contribute to management process. The server program running on the agent can check the environment, and if notices some unusual, it can send a warning message called a trap to the manager. In other words, Management with SNMP is based on three basic ideas. A manager checks the agent by requesting information that reflects the behavior of the agent. The manager focuses an agent performance by resetting the value of the agent database. It continuously checks the value whether they are below or upper the below or up the upper side of the normal values. If there is some deflection, so SNMP agent will inform to the manager there are some problems. So manager will take care or manager itself will take care. An agent contributes to management process by warning the manager of unusual situation. Agent can also send a signal as I have discussed. SNMP requires two other protocol. First one is the management information. Second one is the management information base. So firstly, I am going to discuss about the structure of management information SMI. This is the protocol that is used in the SNMP. SMI defines the general rules for naming objects, defining objects, including range and length. Means variable length, objects, and corresponding to that variables, what will be a range of which type is the object, and so on, and showing how to encode the objects and values. SMI does not define the number of objects an entity should manage. Means how many objects, that means agent, can be managed. So it do not define this one. Or name of objects to be managed or define the association between objects and their values. That means how the naming convention of the objects, naming of the objects, how it can be managed, or what are the association between objects and their values. The management information base. MIB creates collection of name objects, their types, and their relationship to each other in a entity to be managed. So MIB is responsible for all these. Yeah, how they are correlated with one another and what are the relationship between them. SNMP has some very specific role in the network management. It defines the format of the packet to be sent from the manager to agent or agent to manager. It also interprets the results and create the statistics, often the help the management software. For example, how much bandwidth is used by the a particular system or a particular server. Is it higher side than the prescribed one or at the lower side? Which switches or which router is not working properly? So all things are managed by the SNMP. The packets exchange contains the object variable names and their status. The packet exchanged between manager and agent contains object variables, means name, their status in terms of value. SNMP is responsible for reading and changing these values. So to manage, the SNMP uses five messages from server to from manager to agent: get request, get next request, send request, get response, and trap. So firstly it will send a get request message to SNMP agent. What is your status, kindly send me. Then after it can send the next request also, or it can get bulk request for each. For example, overloading, bandwidth consumption, etc. So there may be a bulk of request may be also sent, or it can send the set request, means you cannot use the bandwidth more than this, or a particular area have the network facility at the particular time. For example, in hostels, there will be no internet connection during the class hours. So there will be a script run by the manager to manage the agents, means switches or routers or servers, so that the internet facility will be blocked during the college hours. To overcome the problems, all students must be at the in the classrooms. In the after the working hours, it may be possible the bandwidth consumption of the office hours is approximately zero. So that bandwidth must be sent to the students' hostel, so that the better utilization of the bandwidth, or a student can access the data with higher speeds. So we can set the script after 5 o'clock, the services or the bandwidth to the admin office will get blocked, and the bandwidth of the admin block will be handed over to the hostels. So these are the basic components or the messages that exchange. Corresponding to these messages, the SNMP agent sends a response. If there is any problem, it can send the trap message also. So get request message sent from the manager to the agent to retrieve the value of variable. The next get next request message is sent from the manager to the agent to retrieve the value of a variable. This type of the message is used to retrieve the value of the entries in the table. If the manager does not know the index of the entries, then it will not able to retrieve these values. In such situation, get net request is used to define an object. So its one more purpose is to define the object also. Get response. The get response message is sent by the agent to manager in response to the get request message or get next request message. The message contains the value of the variable requested by the manager. Whatever the value requested by the SNMP manager, it will return back to it. Set request. The set request message is sent from manager to agent to the set the value of the variable. Trap. The trap message is sent from the agent to manager to report an event. For example, if the agent is rebooted, then it informs as well as send the time of the rebooting. So trap is a particular type message, means when it is not performing its actual action that it should, so it will send the a trap message, means there is some unusual activities found at the SNMP agent. It will inform back to the SNMP manager. Now, function of the network management system. So these are the five functions used by the network management system. First one is the configuration management, fault management, performance management, security management, and accounting management. So we will discuss each one by one and explore. First one is the configuration management. Configuration management we are discussing. A large network is usually made up of hundreds of entities that are physically or logically connected to one another. These entities have initial configuration when the network is set up but can change with the time. The desktop computer may be replaced by other. The application software may be updated to a newer version, and user may move from one group to another group. So how to configure, how to update this? The configuration management system must know at any time the status of each entity, its relation with other entities. The configuration management can be divided into two subsystems: reconfiguration and documentation. Configuration at the first time when the software or the hardware get installed, and then after, if there is a change, then how to reconfigure it. And once it is reconfigured, it should be documented or updated. Updation in the documentation: earlier the value was this one, now the value is this one. So here is the reconfiguration. The reconfiguration, which means adjusting the network component and the feature, can be a daily occurrence of the large network. There are three type of reconfiguration. Hardware reconfiguration means hardware is has been changed. Software reconfiguration, the software may be updated. Or the user account reconfiguration. Suppose that earlier a user was a general user. Now there is a need of the admin, or we want to give some extra rights to him or her. So user account configuration will be there, or we want to remove the some permissions. So user account configuration will be there. Documentation: the original network configuration and each subsequent changes must be recorded continuously. This means there must be a documentation for hardware level documentation, software level documentation, and user account relative documents. What are the configuration at present at the hardware level, at the software level, and what are and who are the users who are using the hardware or software, and what are the rights or the permission given to the that particular user. Second one is the fault management. The fault may occur at any time in the system. So there is a need of the overcome from that fault. So the complex network today are made up of the hundred or the thousand of the components. The proper operation of the network depends on the proper operation of each component individual and in relation to each other. Means they must coordinate to one another. The fault management is the area of the network management that handles these issues. The effective fault management system has the two subsystems: reactive fault management and proactive fault management. Reactive means after happening the fault, it will allows to overcome, or in proactive, when there is some symptoms, yes, fault is going to occur. So it will take precautionary measurement to overcome or to do not allow occurrence of fault. So, firstly, we are discussing reactive fault management. A reactive fault management system is responsible for detecting, isolation, correcting, and recording the faults. Means, firstly, it will detect what is the fault, and then after isolate that network component, correct it, record the faults, what are the faults, what was the reason, and how to overcome from this, and after overcoming, again reinsert into the main system. It handles short-term solution to the fault. Proactive fault management try to prevent the fault from the occurring. Already it will check for the some term conditions. If there is some abnormal, so it will try to overcome from the fault that is going to occur in the near future. Although it is not always possible, sometimes the failure can be predicted and sometimes cannot be predicted, If sometime predicted, then they can be prevented. So proactive fault management means after seeing the symptoms of the system, we will try to overcome, or we will do not allow to enter the system in the situation where the fault will occur. When the system is executing, so it is necessary to measure the performance, how the system is performing. The performance of the system is based on some parameters that are your capacity, traffic, throughput, and response time. If network has higher or larger traffic than the network capacity, so automatically performance will get degrade. So traffic must be below than the network capacity. If the traffic will increase then the capacity, automatically the throughput of the system will get decreased. Once the throughput will get decreased, the response time means automatically get decreased. So each and everything depends on the traffic and the capacity of the system. So if the capacity of the system is higher, then throughput will be higher. If the capacity of the system is higher, the response time will be lesser. So there is some relationship between traffic, capacity, throughput, and response. So they are interrelated to one another. Capacity is one of the factor must be monitored by performance management system. The management system. Every network has a limited capacity, and the performance management system must ensure it should not used above this capacity. Means maximum capacity is a limited. There is a limitation of the maximum capacity, and the load should not go beyond the capacity. Traffic can be measured in two ways: internally and externally. Tra- Internal traffic is measured in terms of the number of packets, bytes inside the network. External traffic is measured by the exchange of the packets outside the network, going outside. Throughput we can measure as individual device such as router, server, etc. A part of the network. The performance management monitor the throughput to make sure that it is not reduced to unacceptable levels. Means throughput must be up to a acceptable level. Response time. Response time, as I have discussed, it is the amount of work done in unit time. Response time is normally measured from the time a user requests a service to the time service is granted. Other factors such as capacity, traffic can affect the net response time, as I have discussed earlier. The performance management monitor average response time and the peak hour response time. Any increase in response time is very serious condition, as it is an indication that the network is working above its capacity. So if the network is working below than its natural capacity, then response time will be okay. Otherwise, response time will be higher. Next one is the security and accounting management. The security manager is responsible for controlling the access the network based on predefined policy. Means who will access, for how much time it will access. So there should be, who will access the resources. So this is measurement of the security. Last one is the accounting management. The accounting management is the controls of the user access of to the network resources through charges. The organization uses the accounting management system for the following reasons. It prevents user from monopolizing limited network resources, means only a single person is using all the resource or bandwidth. It prevents the user from using the system inefficiently, means if I do not want to allow the hostlers to use the net and internet during the college hours, so we can restrict that. The network manager can do short or long term planning based on the demand of the network. Yes, this much amount of the bandwidth will be allocated to registrar office during the fill up of the examination form by the registrar office. So, so that there should not any interruption or the continuous service to the registrar office for accessing the internet. So this type of the services or the accounting management or the security management is done by the SNMP. Now, the question arises what the SNMP can do. Last one, it provides read or write ability. For example, you can use the reset the password remotely, IP configuration, etc. Collect the information, how much bandwidth is being used, collect the error report as a log, useful for troubleshooting or identify the trend, email and alert when the server is low disk space, monitor the server CPU memory use when it is crossing the threshold value, page or send an SMS when a device get failed. Suppose that in my server room, the due to the CPU UPS fault, the system get down. So it will be immediately informed to the network administrator. Now this server is not working. DNS server or the web server is not working due to some regions. Kindly do the or needful or take the appropriate action. If suppose that someone is downloading the movies with the capacity higher than the bandwidth or try to utilize the more bandwidth, so it can be prevented by the administrator. By for this, the SNMP sent the message to the administrator. This IP address is utilizing the network bandwidth by this much amount, so administrator can block that or restrict that user. So this is all about the SNMP. If you have any query, you can send me the mail or ask me directly. Thank you.